My name is Kristen Lumley, and I'm a student at Washington State University in the Executive MBA program. As part of the Masters of Business program, we explored the importance of understanding the emergence of technologies and their impact on business management. Optogenetics is an emerging technology that combines genetics and optics by utilizing light to affect specific neurons in the brain to influence behavior and emotion. The therapy first requires that selected neurons be engineered to be sensitive to light. This is accomplished through the insertion of opsin proteins into a cell's genetic material. The neurons are then triggered utilizing implanted optical fibers within the brain region responsible for processing emotions. Currently, optogenetics research is limited to non-human research and experimentation. However, success in applying the technology to affect the behavior in mice is encouraging. Mice that typically express high levels of anxious behavior have been observed to dramatically change into active explorers of new environments after undergoing optogenetic therapies. Early success in optogenetic research reveals many advantages of this technology. For example, optogenetics will provide much greater insight into the complex functionality of the human brain, including insight into why certain failures in brain functionality may occur. Understanding how the brain operates and what is really occurring will help decrease the stigma often associated with certain psychiatric disorders. Further, existing psychiatric treatments are unable to provide the targeted treatment available with optogenetics therapy. This procedure provides high levels of control over specific brain circuits, giving new insights into a variety of disorders, including epilepsy, Parkinson's disease, and anxiety disorders. Optogenetics may also provide new insights and therapies for treating traumatic brain injuries by enabling scientists to confirm and prove correlations between specific neurons and behavior. Finally, optogenetics may allow the stimulation of brain surface rather than requiring invasive brain surgery to treat disorders, limiting the risk of infection or life-threatening hemorrhage. Despite its numerous advantages, controversy of optogenetic research is highly debated. First, it is unknown how effective the therapy will be in the more complex human brain, and human trials appear to still be far off. Secondly, the procedure involves bioengineering that tends to raise concerns regarding the dangers and ethics of manipulating the brain. As optogenetic research continues to evolve, the ability to control a patient's mind in very specific ways becomes more plausible. This is a frightening possibility for many. For example, could a patient with implanted optogenetic technology become a victim of hacking, allowing someone to control their behavior other than was intended by the initial therapy? While this example is likely extreme, at least in the early advances of optogenetic therapy, the question of ethics of any level of brain manipulation remains at the forefront of scientific debate. Current therapies for treating impaired brain functionality disorders include drug treatments and transcranial magnetic stimulation. Existing drug therapies lack specificity. Drug therapies basically dose the entire brain with serotonin or dopamine, hoping to hit the right area of the brain that may or may not respond to the drug and balance brain chemistry. Transcranial magnetic stimulation also lacks specificity and fails to focus on the area of the brain that is suffering from the imbalance or impairment. Optogenetics' ability to pinpoint specific neuron receptors and act only on those key areas indicate that this technology will be much more effective compared to current alternative therapies. Recently, the American startup company Kendall Research announced the creation of a wireless optogenetic device. The device is equated to a wireless router for the brain. Prior to this device, the application of optogenetic technology required hard-wired circuitry, which was far too bulky to connect to a subject, while enabling mobility for effective research. The device developed by Kendall Research weighs only a few grams and is wirelessly controlled by a computer. Additionally, rather than large lasers, the device utilizes small, efficient LEDs and laser diodes. Kendall Research can now successfully connect the device directly to the head of the research rat. Researchers could then manipulate the rat's behavior through interaction with the computer's keyboard. This advancement takes optogenetics one step further toward actual human application and the treatment of disabling brain disorders.